Hello, and welcome to my final project for Computer Science 4900 at Ohio University, which is game engine design. For my final project, I attempted to implement rocket physics into our game engine and also explored PhysX triggers. So the inspiration for the project was to recreate the rocket jump mechanic found in some video games. So you can see an example on your right there. But the rocket jump is when a player shoots an explosive weapon, around at the environment around their character and uses the blast to propel their movement. It's pretty unrealistic, in the real world, but it's a ton of fun to do in video games, so I figured I would give it a shot to see if I could implement it and see kind of, what goes on behind the scenes in the games I like to play. So the original plan and the milestones I set were to first complete the modules with a heavy focus on PhysX, so trying to use it as much as I could so that I could have a solid basis when officially starting this project. The first thing I wanted to do was launch an object from the camera, so kind of imitating shooting a rocket, straight out in front of you. The next part would be checking collision through PhysX triggers. This would be checking what the rocket hits and then doing things based on where it hits and what happens. So creating an explosion around where it hits, or moving anything it runs into, or even despawning the rocket after it's collided with something. So in the third milestone I set would be to create an explosion off of wherever the rocket hit from the previously defined triggers and apply forces to the player and objects around the player, or around the explosion. Then finally I figured if I had extra time I could create a map and make a game out of it. So what did I actually complete? Well, I completed all the modules, and as soon as I was able to finish the physics module I started focusing on learning PhysX. I was able to launch an object out from the camera, which we'll see later on in the demo. I was able to start implementing PhysX triggers. I was able to rewrite inherit a couple of the functions and get some objects to trigger, but not everything would trigger when they collided all the time, so it wasn't working fully and I wasn't able to do much with the triggers. I was able to create an explosion and apply forces, but because I couldn't do it with the triggers, it wasn't as impressive because it wouldn't seem like it was coming out of the rocket. We'll see more later on in the demo and it'll make a little more sense. And I also didn't have it affect the player at all. I didn't implement a player model. But it affects the rest of the world. And then finally, because I didn't have everything done, I didn't take the time to go ahead and create a map and make a game because I was trying to clean up everything else. So here we are loaded into the engine. As you can see, we have this pencil down in front of the screen that follows the camera. This was supposed to be sort of like a part of the view model for the player, so you have an idea of where the rockets are coming from. When you move, it doesn't keep up fast enough, so it kind of disappears, although if you slow down a lot you can see how it just kind of stays right behind. I wanted to fix it, but there are more pressing issues, so I'm kind of satisfied with it for now. But yeah, just a little way to spice up what's going on. So the first thing was making physics and being able to launch objects out of the camera. So when we go ahead and press F, the first object always flies off way too far, but then you can see we shoot these spheres out and they bounce and collide with things. So then the next thing was the triggers, but it's kind of hard to see those. I'll explain more of that when we get into the code, but here I'll pull up the console as well. You can see that here we go. When we fire these balls, we get a trigger. Pause this real quick. We get a trigger from the rocket's objects, which I'll go into more detail about this in a minute, and a trigger when the rocket hits the grass. So then go ahead and reset these blocks right here. So I was able to implement explosions, but they don't happen on the trigger. So instead, I just made it similar to the way that the balls spawn out in front of the camera. I just have an explosion come out up around here in front of the player. So if we go ahead and walk up to these blocks, and see, you can see it pushes them all away. We can go ahead and reset them, and then knock them in any direction. We can even kind of chase after them, knock them around a bit more, and that creates a 3D sound as well. Obviously it's close to the player, but if it was able to happen on the trigger, then you would hear it come from wherever the trigger's happening. So to sort of give an example of what the desired goal would be, just by mixing everything together, this is what we'd want it to look like, is shooting a rocket, and then once it hits the objects, it blows them all away. Maybe from a different little angle here, we have shoot the object, blows everything. But yeah, now let's go ahead, I'll move on to the code and explain sort of how everything works, and more so what does and what doesn't. So let's talk about PhysX triggers. So a trigger is just something that happens when a shape overlaps with another shape. What happens is a callback function gets called during the simulation, and then it sends something to handle the triggers. So how do we define these shapes for triggers to happen? Because it doesn't happen the same, it doesn't just happen on any two shapes colliding. So there's two flags that I'm highlighting right here. There is the simulation shape flag and the trigger shape flag, and when you define an actor, you can set these flags to the shapes, to its shape. Now you have to, they can't ever be the same, they can't ever both be true or both be false, because they contradict each other. PhysX trigger shapes, when they're actually trigger shapes, they don't take part in the simulation. So gravity doesn't affect them, nothing really can, they can't collide with something, they won't bounce off or anything. Basically physics don't apply to them. So what you have to do is you have to make a simulation shape, and then you have to also make a trigger shape, and then you just have to let the simulation shape do what it does in the physics engine, and then sync it with the trigger shape, or move the trigger shape to its position all the time, so that when it does overlap with something, it can actually go ahead and trigger. So if we go ahead into the code, here is a class that inherits the PX simulation callback function. So this has a bunch of different event callbacks that can happen while the simulation is running. The main one that we were focusing on is the trigger one. There's also a contact one that's similar to the trigger, but it just happens whenever two objects overlap. I tried implementing this as well, but there's a flag that disables. There's a flag that basically there's sometimes physics tracks every time objects collide or overlap at all. So there's a flag that disables that, and I couldn't find where it was to disable the flag so that it would keep track of all those again. So basically I couldn't really go into the contact one. But the trigger, so what happens is there is a trigger, and then you get a pair of actors, which are these trigger actors, and then you do something. So here's where I tried to create an explosion off of the rocket hitting the grass, but just didn't work in the engine, and I'm not sure why. So yeah, but anyways, let's go ahead and talk about, so I'll show you how we do the objects. So here is where we actually shoot the rocket. It creates a spot in front of the camera that it will spawn, and then it maps it pairs the two objects together. So this is pretty much the same function where they are just defining a world object and a physics actor. But the main difference is here you see, it's not it. Well, let's reset the name so we know the difference. But yeah, here we go. Here are the flags. So this one's a trigger shape. So this one, it does not respond to the physics simulation at all, but it will respond to colliding with another trigger shape object. Then up here is its counterpart. So it is not a trigger shape, but it is a simulation shape. So it'll just behave like a regular physics object. Then up on our update world, we have the map of all of our rockets, and then we set the position and display matrix of the trigger object to the simulation object, so that it's always moving along. And we have the same thing for the boxes down here because they also have trigger objects. So let's talk about the explosion. The way that works is first we pass in the point that'll be the center of the explosion. So we have a function up where we're in our button presses where it just gets the camera location, gets the direction the camera's looking, and then picks a point that's like 15 units in front of it or something. We go ahead and send a message to the console, make an explosion sound, and then this is where it starts to get interesting. So here we're getting all the active actors. So you probably saw in the demo how I kept resetting the cubes because I was trying to figure out just the regular get actors function, but I couldn't. So for the sake of time, I just went with this because I was able to actually get it working. So it gets all the actors that have been updated within the last cycle and adds them to a list. So then it goes through, goes and casts it as a world object, and then makes sure it exists. And then it goes and it gets the position of the object, and then checks the vector from the center of the explosion to the center of the object. So I originally thought about having it, affect every single object in the world, but then I realized that's super inefficient, and like we're not really going for realism. Obviously, we're trying to jump with rockets. So if it's greater than if the distance between them is greater than 15 units, then it just doesn't affect it at all. I went ahead and squared, did the formula, but I just didn't square root it because I didn't want to add in that calculation. I figured it was just fine. So then here you just print some stuff, has the force of the explosion, and then adds the vector, adds the force to each component of the vector of the explosion, the direction towards the object, and then applies it. So originally when I was doing this, I had the formula following this graph right here with the cutoff being around, I think I had the cutoff being around 40, but then I realized I was super far, so I toned it down a little bit. But I wanted it to make it so that when you had the explosion like right next to you, you'd have like a ton of force, and if it was like a little further away, you'd still have some force, but not as much. I figured it would be a little more interesting and a little more like noticeable if it scaled exponentially. So I set like a max cutoff so that it wouldn't, because at first it would just, you'd shoot right at a block or something, and it would just disappear because the force would be infinite. But what ended up happening was because the exponent had to be negative, and sometimes the values for the vector were negative, it would cause domain errors, and it would just not work, and then you couldn't put the force in. So I had to make it just flat, just to get it working. But in an ideal world, it scales with that nice, beautiful curve, and it's a little more interesting. But it still works for now. There's just haven't been able to figure out a way to get the trigger to actually call this. So at the end of it all, I think if I could go back and do it again, I would have started work on everything a little bit earlier and given myself some more time to actually figure out the PhysX triggers and like get those working. I think that was what was really holding this project back as a whole, because once I had those, if I had those going, then that's the main part of this project. So being able to blast everything around would mean I just have to tweak the numbers and just sort of clean everything up and make it look nice, make it run smooth. Maybe make it into an actual game with like like a goal that could happen when like an event that happens when you reach it. But overall, I do think I learned quite a bit about PhysX and moving things around in a 3D environment. I spent a lot of time just scouring the PhysX documentation, trying to get everything working correctly, but obviously it didn't pay off super well. But I did enjoy it, and now I have this nice little pea shooter demo to play around with. So thank you for watching this presentation. I hope you enjoyed it, and take care. Have a good day.